Okay, so for this lecture, we will now discuss the chi-square test. So, the chi-square test has basically three tests. The first one is the so-called the goodness of fit test. The second is the test for uniformity. And for the last one, we have the test for independence. So we will first discuss the chi-square goodness of fit test. So here's the definition. So a chi-square goodness of fit test is used to test whether a frequency distribution fits an expected distribution. So basically, the null hypothesis of the chi-square goodness of fit test would be the frequency distribution fits an expected distribution, and its alternative hypothesis would be the frequency distribution does not fit the expected distribution. So in a chi-square goodness of fit test, we have a so-called observed frequency, which is the frequency for the category observed in the sample data, and the expected frequency of a category that is found by using the expected or hypothesized distribution and the sample size. So the expected frequency for the ith category is described by the formula E sub I equal to N times P sub I, where N is the number of trials or the sample size, and P sub I is the assumed probability of the ith category. So to perform a chi-square goodness of fit test, so these conditions must be met. So the first one, the observed frequencies must be obtained using a random sample, and the expected frequency must be greater than or equal to 5. So if these conditions are met, then the sampling distribution for the test is approximated by a chi-square distribution with k-1 degrees of freedom, where k is the number of categories. So the test statistic is described by this formula, where O represents the observed frequency of each category and E represents the expected frequency of each category. Alright, so let us do this example. So a retail trade association claims that the tax preparation methods of adults are distributed as shown in the table at the left below. The tax preparation company randomly selects 300 adults and asks them how they prepare their taxes. The results are shown in the table at the right below. At alpha equal to 0.01, test the association's claim. Alright, so let us analyze the given problem using the software SPSS. So before that, let us complete the steps in hypothesis testing. So before I record this video, I already give you all the necessary information in the steps in hypothesis testing. So let us just analyze each steps. So for the claim, so in the given problem, the claim was the distribution fits the expected distribution. So as you can see in the table, this is what you call the expected distribution, and your sample would be your observed distribution. So the claim will be put it in HO. Now for HA, so we just write the distribution does not fit the expected distribution. So for the level of significance, we have 0.01. The statistical test, we have chi-square. So let's go on to the p-value. So why is it there's a 0.002 here? So let us analyze. So I already encode the data for the analysis. So let us just analyze the codings. So if we go to variable view, you will see this assigned variables. So for the group, we have a label here, tax preparation method, and then we go on to values. So if we click here, you can see the codings. So we have 1 accountant, 2 by hand, 3 computer software, 4 friend or family, and 5 tax preparation service. Now the other coding would be OBS for observations. And then we go back to data view, and then after before the analysis, we click this data and then weight cases. As you can see, the OBS data is in the frequency variable box. So you click OK. So you close this. And then for we can now run the analysis. So we go to Analyze, non-parametric tests, legacy dialogues, chi-square. So you will see this kind of dialog box, and then you put tax preparation method in the test variable list. And then as you can see, we have this kind of values here. So these values are the expected frequencies. So recall that to compute the expected frequency for each category, so we will use the formula n times p sub I, where p sub I is the probability in the ith category, and n be the number of samples. So for example, why is that there's a 72 here? If we multiply 300 by 24%, you will get 72. And then for the second one, we have 300 times 20%, so you will get 60, then followed by 105, 18, and 45. So we are almost done. So we now click OK, and this will be the result. So we will focus at the p-value. So as you can see, there's a 0.002 here. So this is your p-value. That's why we have a p-value 0.002 here. And then for the decision, so since the p-value is less than 0.01, we will reject HO. And for the conclusion, there is a sufficient evidence to reject the claim. Okay, so for the next test, so we can also use chi-square to test for uniformly distributed. So to illustrate that, let's have this example. So a researcher claims that the number of different colored candies in bags of dark chocolate M&Ms is uniformly distributed. To test this claim, you randomly select a bag that contains 500 dark chocolate M&Ms. The results are shown in the table at the left. At alpha equal to 0.10, test the researcher's claim. Okay, so let us now analyze the given problem. So I already have the steps in hypothesis testing. So I already fill in all the necessary information here. So the claim was the distribution is uniformly distributed. So this claim will be put in HO. And for the HA, the distribution is not uniformly distributed. So the level of significance was 0.10. The statistical test, we have chi-square test. Now for the p-value, so we will use again the software SPSS. So here for the coding, it is just the same as our coding before, but as you can see, so I just edited the label, also the name of the variable. So here are the values. So do not forget to click data and then weight cases, and put obs in the frequency variable box. Alright, we can now run a chi-square test. So we will go to Analyze, Non-Parametric Tests, Legacy Dialogues, and then chi-square. So you put color in the test variable list, and for the expected values, you just click this all categories equal, since the probability in each category are equal. So we may click now OK, and we have the result. So as you can see, the p-value was 0.698. So it is greater than the designated level of significance. So our decision would be fail to reject HO. So for the conclusion, so there is a sufficient evidence to support the claim that the distribution is uniform. Alright, so before we go to the last test for the chi-square, let us first have this definition of a R by C contingency table. So an R by C contingency table shows the observed frequencies for two variables. The observed frequencies are arranged in R rows and C columns. The intersection of a row and a column is called a cell. Alright, so we now begin to the chi-square independence test. So a chi-square independence test is used to test the independence of two variables. So using this test, you can determine whether the occurrence of one variable affects the probability of the occurrence of the other variable. So to perform a chi-square independence test, these conditions must be met. So the first one, the observed frequencies must be obtained using a random sample. Number 2, each expected frequency must be greater than or equal to 5. So if these conditions are met, then the sampling distribution for the test is approximated by a chi-square distribution with df, or the degrees of freedom, equal to the number of rows minus 1 multiplied by the number of columns minus 1. And then for the test statistic, we have the formula given below, where O represents the observed frequencies and E represents the expected frequencies. Alright, so for example, the contingency table shows the results of a random sample of 2,200 adults classified by their favorite way to eat ice cream and gender. The expected frequencies are displayed in parentheses. At alpha equal to 0.01, can you conclude that the variables favorite way to eat ice cream and gender are related? Alright, so here are the steps and the necessary information. So the claim was, so favorite way to eat ice cream and gender are related. So this claim would be put in HA. And then for HO, so favorite way to eat ice cream and gender are not related. For the level of significance, we have 0.01. The statistical test, we have chi-square. For the p-value, so here's the coding for chi-square test for independence. So as we can see, we have x1 and x2 here. If we take a look at the variable view, so we can see that x1 is gender and x2 be favorite way to eat ice cream. And then we also have obs for observations. So do not forget to click data, weight cases, and put observations or obs in the frequency variable box. So we can now run a chi-square test for independence. So to do that, we go to Analyze, Descriptive Statistics, and then crosstabs. So as you can see here, In the row dialog box, we put gender. For the column dialog box, we put favorite way to eat ice cream. And then after that, we click statistics and click chi-square. And then we click continue and then OK. So here's the result for a chi-square test for independence in SPSS. So we will focus here. So as you can see, so the p-value was 0.000. So there's a very small amount of p-value. So that's why we have a 0.000 here. So since this is less than the designated level of significance, we reject HO and conclude that there is a sufficient evidence to support the claim.